Hello everyone. So we have got this interesting question from the chapter of integration, or from the chapter of from the chapter of integration. So now we have got this weird kind of integral. This is called improper integral. For example, suppose we have got an integration like this. All right, and if a is equal to infinity, or if a tends to infinity, I'm sorry, if a say tends to infinity, or b tends to infinity, or b is equal to infinity, then in that case, such kind of integrals are called improper integrals. Okay, so that is not in the scope of your syllabus, I guess, but let's start solving this. So uh, let's do one thing. Whenever we have got an infinity as one of the limits in an integral, we should try to take 1 by t as another variable. Like, for example, let me write the question first. Okay, so let me write this for you here. Whenever we have infinity as a limit, whenever we have infinity as a limit, we try to substitute the variable, or not the variable, I would say, the reciprocal of the variable with another. For example, here t is the variable, right? So we will consider k is equal to 1 by t, right? K is equal to 1 by t. So now let's replace everything with k. Okay, first let's differentiate this. We need to find dk, right? So dk will be equal to minus 1 by t square, right? Minus dt by t square. Okay, so now, okay, so before we do that, let's make some modifications in the integral. Why? Because we need to accommodate this 1 by t somewhere, right? We need to accommodate this 1 by t somewhere. So I'm going to make one very small change in this question, or in this integral. So if we can replace this ln t, we have got an ln t here, right? What we will do is we will replace this with 1 by t, and we'll put a minus sign before this. Okay, so let me copy this entire thing. And I mean, we do not need to do this inside this function, because it will be the same basically. So dt, is everything okay? Okay, so we need a minus sign over here. All right, so now let's proceed with the integral. If we absorb this minus into these limits, it will be something like this, right? Yeah, everything will remain the same. Everything will remain the same. Now, yeah, now we will replace this t with 1 by k, or yeah. So there won't be any changes inside the function because of obvious reasons. I hope you all know that. Um, Before that, let's do one thing. You know, we need dt by t square here, right? We need dt by t square here. Let's do one thing. Let's multiply t in the numerator and the denominator. Okay. So basically, this entire thing will become dk. All right. Yeah. This entire thing will become dk. All right. Dk. And this t will become 1 by k. Right. This t here, it's basically 1 by k. Right. So essentially what we have here is I. Right. Did I make a mistake somewhere? Oh yeah, I made a minor mistake here. That is, okay, yeah, I made a mistake here. You see, this actually, for this to be dk, for this thing to be dk basically is minus dt by t square, right? So we'll also have a minus here. All right. So if we replace this k with t, now we know that integration a to b fk dk will also be equal to integration a to b ft dt, right? We have just changed the variable, nothing else. Both these integrals will remain the same. So we take this particular equation and if we replace everything over here, this will basically be ln t by t dt, right? So this is this basically means I equal to minus I, right? So I is equal to 0. Now if we have a look at the question, we need to find this e to the power sine x, the number of solutions for e to the power sine x equal to 0. That's what we have to find, right? E to the power sine x equal to 0. Tell me one thing. Is e to the power x ever equal to 0? Never, right? It's only possible when x tends to minus infinity, right? But will sine x ever tend to minus infinity? Sine x will ever tend to minus infinity. The range of sine x, if you look at the range of sine x, it's between 1 and minus 1, right? So the value of e to the power sine x will always be in the range e and 1 by e. Yeah. So it will never be 0. Okay. So the number of solution, the answer basically will be 0. There you have it. The answer for this question is 0. Thank you.